Hi, good morning to everyone. In previous session, we discussed about derivation of torsional equation. When a shaft is subjected to some amount of torque at the free end, due to this torque, some amount of shear stress will generate. Okay, it will change to material. So that for that applied torque, we derived some equation, that is T by J equals to Q by R equals to Z theta by L. Okay, and we discussed the polar moment of inertia. Based on that, polar modulus we derived. Okay, next in this class, I am going to discuss about power transmitted. Okay, all we know, power is defined as the rate of doing work. Okay, in this concept, amount of power is developed due to the application of torque. Okay, when we applied an amount of torque to the shaft, what happened? It will do some work. Okay, that work per second, okay, is known as work. Work done per second is known as power. Okay, now consider a shaft subjected to a torque T, okay, and rotating a speed of n revolutions per minute is known as RPM. Next, the time, taking second as a unit of time, then angle through which torque move, the formula is n by 60 into 2 pi. Actually, 2 pi n is the formula of angular velocity. By dividing 60, that means rotation, revolution per second is known as 2 pi n by 60. Okay, next, the formula for power already discussed, that is work done per second. Work done is torque into omega, that equals to T into omega, where omega is angular velocity, that is 2 pi n by 60. Next, by multiplying with omega into torque, we will get the formula as 2 pi nt by 60. It is the formula for power. It is also can be written as power equals to force into distance. Here distance can be written as 2 pi Rn by 60. That means a radial distance. Okay, by converting the circular, means circumference of the shaft can be written as 2 pi Rn by 60. So that final formula for power is 2 pi nt by 60. It is also can be written as P is equals to 2 pi nt by 60. Therefore, where T is equals to W into R. It is work done into distance. Next, up to now we discussed the power. Next, units of power. Okay, the power, the units of power varied based on the distance of the center of axis to the surface, that is, and applied force. In some cases, we take newtons, and in some cases, take pounds. Okay, generally, the units of power, that means it is mainly based on torque. If T is taken in Newton meter, then unit of power is Newton meter per second. Okay, it is also can be written as watt. Okay, since watt is a small quantity, so that generally the power can be written as kilowatts. Kilo means 10 cube. Next, generally in previous days, the power is expressed based on the horsepower. Okay, in previous olden days, there is no vehicles. We are going to travel from one point to another point. We use horse, so that the power can be expressed in the horsepower. That is, 1 horsepower is equals to 0.746 kilowatts. Okay, by multiplying the kilo, that is 10 cube into 0.746, we will get the value is 1 horsepower is equals to 746 watts. Okay, what can be expressed in Newton meter per second? So that 1 horsepower is equals to in terms of Newton meter per second, that is 746 Newton meter per second. Okay, because in some problems the power is expressed in horsepower, that is, so that we have to convert based on the calculation, can get convert either kilowatts to horsepower or horsepower to kilowatts. Okay, in that cases we use this formula. Next, observed in this diagram, here by lifting this weight we are using, instead of motor we are using horse, so that 1 horsepower is equals to 33,000 foot-pounds per minute. Okay, it is the expansion of this formula, that is HP. Therefore, by converting the HP, that means 33,000 into foot per minute, foot-pounds can be converted into Newton meter, that is 0.3048 into 0.4536 into 9.81. By multiplying these factors into 33,000, we will get the final value, that is 746 Newton meter per second. Okay, this is the unit of power. Next, coming to torsional rigidity of stiffness of the shaft. Okay, whenever a shaft is subjected to torque, it will get some amount of torque. Already we derived that formula for torque, that is T by J equals to Qs by R equals to G theta by L. Okay, from this equation, T by J equals to G theta by L. By cross multiplying this equation, we will take the term J value to the right side. Okay, the formula is T is equals to Gj into theta by L. Okay, here the torque mainly depends on theta and L. Okay, hence the term Gj may be looked as torque required to introduce unit angle of twist in unit length. Okay, and it is called, the term Gj is nothing but torsional rigidity or stiffness of the shaft. Okay, based on this value G and J, G is the modulus of rigidity and J is the polar modulus. The product of G and J is known as the torsional rigidity. Next, the term is analogous to the term flexural rigidity. Okay, in bending stresses we derive one term, that is flexural rigidity or bending. Okay, rigidity, that is EI in theory of bending. Okay, the same way Gj is nothing but torsional rigidity. EI is nothing but modulus rigidity. Next, okay, up to now we discussed the torsion and shaft, derivation of torsional equation. Next, polar modulus, it is the ratio of J by R, where J is the polar moment of inertia and R is the maximum distance from the center of the shaft to the top surface. Okay, after that we calculated the polar modulus for solid circular section and hollow circular shaft. Next, we derive the power transmitted in shafts. Next, units of power. Next, torsional rigidity, okay, and stiffness of the shaft. This term is mainly used to find the strength of the shaft, okay, due to the application of torques. Okay, next section I am going to discuss about problems, okay, based on the power transmission, torque developed and angle of twist, okay, and radius. Okay, all these will calculate by using the different formulas. Okay, thanks for watching.